Hi everyone, in this today's video, I'm going to demonstrate a better version of our last project, Practical DevOps. With every item in the architecture that we are seeing right here, I'm going to add some advanced feature to enhance our whole architecture, whole project, make it better. So the first item I'm going to add is called a Helm chart. It will help us manage Kubernetes manifest files with better management and easier to install, to remove all the pod service deployment super quickly and easily. And this will be the requirement for this project. Use the Helm chart to manage the manifest file instead of using just only manifest file of Kubernetes like the last project. So that will be the enhanced feature file ops repo. We're gonna replace the whole Kubernetes manifest file with the Helm chart right here. And we go to the next feature that I'm going to add for this project. So like the last time, we have the Terraform provisioning the whole resource right here, which include the VPC, EC2, Istio, and EKS. In this time, we're still going to do the same way, but we need to make it have higher availability by using multiple availability zones. And we will need to create our own VPC instead of using the default one like the last time. And next, like the last time, we are still using the same CI pipeline, which is Jenkins. But this time we are going to give it a little upgrade by adding Trivy, which is a tool to have us scan image, workspace, and relevant things to help us make our code, our images more secure by providing us information of our code based on the level from low to critical. So that would be our CI flow with a little upgrade of Trivy around here. In our previous project, for the monitoring section, we use Prometheus and Grafana to monitor all of the EKS Cluster resources. And this tool will help us gather information, metrics, and visualize on Grafana. In this time, to make it a little better and more informative, I'm going to use the Istio to provide more observability metrics, and it can be visualized by using Grafana and Prometheus as well. Finally, we're going to have a look at our CD pipeline. Instead of Jenkins, we are going to use the ArgoCD as our main CD pipeline in this project with some advanced feature called image updater, as we can see in the diagram right here, as well as the assignment overview, as well as the requirement. And we also try to apply some deployment strategy, which we are going to use the blue-green strategy. So that is our assignment overview for this video. Alright, so to get started, I'm not going to follow the exact order of the assignment task right here. I will put it in my way so that it will be a cleaner flow and to make sure that everything will work just perfectly. So the first feature we're going to add is making the cluster highly available by putting it into multiple available zone and in its own VPC. So here I created a VPC, and in this VPC I declare the availability zone with this following variable. In this variable I have declared these following zone: US West to ABC, to make it highly available with a multiple zone. And the EKS cluster going to use that VPC ID, which is right here. And I already have the EKS cluster up and running, so we can have a look. This is our cluster, and in networking we can see it has 3 subnet in 3 different zones right here, and that will meet our requirement for the EKS to be highly available and in a custom VPC instead of the default one. So with our cluster created in multiple zone, next we are going to set up the Jenkins CI pipeline with the support of Trivy scanner. Here I already have the Jenkins setup on our own EC2, so I'm just gonna go ahead and log in. My Jenkins is already configured from the necessary plugin to the credential that we're going to use. So I'm just going to go ahead and create the CI pipelines for our project. So I'm going to call it front-end CI. I had created a template earlier, so I'm just going to go ahead and copy from it to save our time. That's everything configured. Seems correct, so I'm just gonna go ahead and save. So our front-end CI pipeline is created. I'll create another CI pipeline for backend. Do the same step. And it goes to the same repository with the credential I already set up. Let's change this right here. Save. Now we have pipeline ready. The next step, we're going to need to install the Trivy scanner. So we'll go ahead and connect to our EC2 instance. Okay, it is ready. I'm going to install the Trivy scanner by using this following command. And to see if it's up, Trivy is ready. So with the Trivy installed successfully, we can now scan our image or workspace using the Trivy. Let's have a look at my Jenkins file. So it's just the same as the last time. Nothing changed much. We have some of the environment variable, some of the step. We clone the repository, we build it, we deploy it. This time, I am going to add an extra step called Trivy scan. and I will scan our workspace and then scan the image that we build and push to our Elastic Container Registry. So let's go back to our CI pipeline and try them out. I run the front end. I run this. Okay, let's go and have a look. Okay, so the pipeline is running. Let's have a look at the console output. Start pulling the sort and start building the image and push to the registry. And after that, it will be scanning. So you can see right here, scan our workspace. It will feedback with some of the information. Right here we have 2 vulnerability with high level and 1 with critical level. These return nothing, and then it will scan our image that we just push, and the image seems fine, doesn't have anything. That's technically it. That's our Jenkins pipeline with Trivy scanner. So with the Jenkins CI pipeline and Trivy done, we will go and implement the Helm chart to manage the Kubernetes manifest file, and we're gonna make it work along with the ArgoCD as well, and it will be our main CD pipeline along with these following features like image updater, and we're gonna try to apply some deployment strategy, which is blue-green deployment. So let's go over the Helm chart folder structure. So I have a folder right here, and inside I have a chart with multiple subfolder, and it's split into services of my application that are backend, frontend, and MongoDB, and all of them share the same structure. They have a subfolder called templates, which contain the deployment service and ingress manifest files. In this file, instead of the hard-coded value right here, we're going to have some placeholder that will take the values from our define values YAML file. You see, it will contain some of the values with the name and the value itself, and it will take all the value from this file, and all of the service will have a similar structure. In order to apply the Helm chart, first of all, we're gonna need to run the following command: Helm dependency build. This will pull all of the dependencies that we define in the main chart YAML file right here. And next, you can use this command helm install with a custom name dot to apply and deploy all of the chart in this folder. But I'm not going to do that. I will use ArgoCD to have us deploy by pointing ArgoCD to the Helm repository. So let's go. Right here I have ArgoCD setup. So I will create a new application. Let's call it my Helm app. I want you default. Everything is default. And I will input the repository URL here. And we'll target to our Helm repo right here. So yeah, Helm apps. Destination, I'm going to choose the cluster default service. Namespace, we use EKS namespace. You can see it loaded all of the values file. You can go ahead and hit create. I'm gonna go ahead and hit send. Check all the resources and hit synchronize. You can see the Helm chart is installed and it's pulling over dependency and applying all of our services. So it could take a while. I'm going to fast forward this and I'll see you when it's done. Okay, so the application is sent and deployed. The app health is also healthy. And you can see it target to our image that we built earlier. So let's try and access it. I use an ingress so we can access it using the load balancer URL. And here we go. Our application is up and running. Let's try. Perfect. So that is how the Helm chart works, and I make it to work along with the ArgoCD as a CD process. Okay, our application is already up and running. Now we can go ahead and apply ArgoCD image updater. With this feature, it can help us listen to the chain in the registry right here. So whenever we push a new image to this registry, it will listen to it and update the image tag inside of our operator repository, and then it will trigger the CD flow so that will deploy the newest, latest image to our cluster. So here we go. I'm gonna go and install the ArgoCD image editor using this following command. Next, we're gonna need to edit the config map and input some of the configuration to make it work. With this command, we'll open up a file so that we can make change to the file. I'll input these following data. We'll have a log level debug, registry configuration. We'll have the name, the prefix of our registry URL, the API URL with the HTTPS, credential that we're going to need to pull. So let's save, close it, to set it. Now I will need to create a secret so that the image editor can pull from. So this will be the secret for the ArgoCD image editor to access to our registry. This command will create a secret with the following name and target to the Docker server, which is our registry server. Just name it AWS, and I'm gonna log in with our password. And we have it configured. So that's the first one. The next credential is GitHub, so that the image editor can have access to our GitHub repository and do some changes on the tag. So here's the command. We're gonna create another secret with a generic type, call it a git class, with our GitHub username and our GitHub access token. This is sensitive information, but I'm just gonna go ahead and remove it later anyway, so it's gonna be fine. And before we can get the image editor to work, we'll need to apply this following file. So we'll create another application on the ArgoCD UI. We will target to our registry. With the right target, we will use customization, and here gonna pull the secret from a Docker registry secret and the GitHub secret. I'm gonna target to this repository, and the destination is our cluster. So I will just apply the file. Application.yaml with namespace ArgoCD. Alright, so let's check. Alright, let's see. So the application front is on. Status healthy and sync. Let's check. It runs current image. Now let's try trigger the CI pipeline and the image editor by committing a change to our GitHub repository. So I'm gonna go ahead and change right here. So let's go and have a look at front end. It's building right here because we have a new change. It's listening to it. Alright, so the pipeline is done running. The image should be here by now. Now we just need to check if the image updater works. If it works, you should update the image tag with its current port to 3. You can check the log to see if it's working. So yeah, it detected there's new image. Change from 2 to 3. And we will be committing some changes to our repository. So you can see a new pod is created and the old pod is getting destroyed. With the new pod, it should have the new image tag already. Yes, it does. So that means the image updater works. Here we can see the automatic commit from the image updater that make changes to our GitHub repository. We go ahead and update the old tag to a new tag. So that means the image updater feature is working. Okay, so let's try access it. It should show us the change with the latest update that we just made. There we go. It has. We can make some change. And the apps still work just fine. So that is the ArgoCD image updater. Next, we're gonna try to apply strategy deployment, blue and green, to see how it works on ArgoCD. First thing, I'm gonna need to create an ArgoCD rollout controller. Check now, I'm gonna set as default Prometheus. Now check this, so I can make us a new namespace. This here. All right, let's try create it. Okay, so rollout is ready. Now we can deploy blue-green application. I'm gonna create a new application, call it blue-green. Check name I set default. Keep everything normal. And I still target to the same repository. This time I'm gonna target to the blue-green application. Same destination for cluster and the namespace. I'm gonna use the namespace of our main project. Create. And sync. While waiting for it to sync, you can go over the blue-green application manifest files. So in here we have 3 different files. Two of them are service file, included the review and the main active. I'm gonna target to the same port but with different node port. And our rollout YAML file is the main file that we need to care about. It will target the active service with the following name, then review service. We set the auto promotion enable true, and we match the following label, and we target to our tag right here with the tag blue. I already repaired two images on the ECR registry. It's called blue and green for this. So the CI application should be up now. Yes, up. Let's see. It run the blue tag. Let me try and forward the port to that pod, and we can see. So let me try to see what's the service name. So we're gonna forward the port to this service right here. In the namespace, EKS NS from the port AA to 3000. Well, let's check it out. So yeah, right now it's a blue application. Let me try and change it to green application, and we can see how the workflow is like. Okay, it pushed to our repository. Okay, so now we just need to sync it again. Synchronize. So as you can see, it creates a new pod. Right now we have two different versions for the pod. This is blue, this is green. And since we have the auto promotion enabled, soon the blue version will be destroyed, and this one will be the main part that only active. See here, you can see it being terminated. There we go. Now only the green version is left. You can try and access it. I'll need to re-forward the port again. Let's have a look. It's not a green application, and that is the blue-green deployment strategy. With the blue-green strategy done, we only have one thing left, is the monitoring with Istio. So let's go and install it. So first we're gonna add the repository of Istio, and we'll install Istio base. And now we're going to install Istio D. Okay, it's done. Let's see the Helm installation in this current namespace. So before that, I have already set up the Grafana and Prometheus. in the namespace Istio system, which is why they are here. But yeah, we can see that these two already installed. In order to make the Istio provide matrix so that we can use it and visualize on Grafana and Prometheus, we will have to install Istio gateway and virtual service, which is here. This is the gateway. Give it a name, use the ingress gateway. It will get all of the hosts possible with this wildcard right here at port number 80. And then we have a virtual service, which will target to our services. Right, let's apply them. First, I'm going to apply the gateway. And then the virtual service. Okay, we can go ahead and get the matrix now. I'm gonna go to Prometheus. I'm gonna use this query and execute it. It will load all of the current pod that's running on this namespace, and we'll query the container memory working set by. We can use the same query to visualize it on Grafana dashboard as well. So let's go and try it out. Go to Grafana. I already set up the dashboard. I have created one earlier. Make sure everything works. This dashboard target to our cluster. You can see all the pods are here. Let's try add a new visualization. Change it to here. And we input the same query. Hit on the queries. And here we go. You can see all of the workload has been going on for these different servers. And that's how you provide Istio metric and get it visualized with Prometheus and Grafana. And with that, we have managed to achieve the whole pie chart program assignment with all of these tasks, from Helm chart, multiple zone for cluster, Trivy with Jenkins CI Pipeline, monitoring with Istio, and ArgoCD pipeline. Thank you for watching and have a nice day.